Good morning, one and all. Today, we are going to solve a simple circuit in a RC series circuit. So, it consists of resistance and as well as a capacitance connected to single phase AC supply. Take down this problem. A series RC circuit with a resistance of 10 ohms and a capacitance of 150 microfarad is connected to a 230 volts 50 hertz AC supply. So here calculate current flowing through the circuit, power factor, power consumed by the circuit, draw the impedance triangle and the power triangle. So what are the given terms? First resistance R is 10 ohms, capacitance C is 150 microfarad. So voltage B is 230 volts and frequency is 50 hertz. So now we need to draw the circuit diagram. So it consists of series RC circuit. So R and C, resistance 10 ohms and a capacitance of 150 microfarad is connected to single phase 230 volts 50 hertz AC supply. Now, what they are calculating is so what they are asking is to find out the current flowing to the circuit. So current flowing to the circuit we need to find out. So what is the formula for current flowing to the circuit? So I is equal to V by Z by using the Ohm's law. So we need to find out what is the Z. So Z is equal to root of R squared plus Xc squared. So here it is capacitance. So or otherwise Z squared is equal to R squared plus Xc squared. So if Z is comes, so this square goes to root. Okay, so now R is given in the problem as 10 ohms. So Xc we need to find out because L only given. Sorry, C only given. Capacitance only is given as 150 microfarad. So capacitive reactance we need to find out. That means Xc we need to find out. So what is Xc? So Xc is equal to 1 pi 2 pi F into C. That is nothing but 1 by omega C. So 2 into pi into F is what? 50 hertz. So capacitance C is 150 into 10 to the power of minus 6 because 150 microfarad, no? So 150 into 10 to the power of minus 6. So if you simplify this, we are getting the capacitive reactance as 21.23 ohms. So the unit of capacitive reactance is in ohms. So now we need to substitute this Xc over here. Okay. So after substituting Xc over here, so we need to calculate the impedance Z. So what is impedance Z? So after simplifying, we are getting the answer as 23.46 ohms. Now we can easily find out the what is the current flowing to the circuit. So I is what? I is equal to V by Z. So V is 230 volts divided by Z is 23.46 ohms. So here current is easily you can find out 9.80 amperes. So that is the current flowing to the this particular circuit. Now what is asked? Next thing what is the asked in the problem is asked is power factor. So what is the formula for power factor? So power factor is nothing but cos phi. So cosine of the angle between the voltage and current. So cos phi is equal to R by Z. Already we derived this R by Z. So R is what? 10 ohms divided by Z is what? 23.46 ohms. So if you simplify this, we are getting the cos phi as 0.426. So this is the power factor. Now we need to find out what is the phase angle from this. So what is phase angle? Phi is equal to cos inverse of. Okay, cos inverse of 0.426. So you can also go for tan inverse also. Okay, and from that impedance triangle, you can also go for tan inverse. Okay, so any one formula you can go for. So here easily you can find out, no? So cos phi you already know. So clearly, so phi is equal to cos inverse of that particular angle. So cos inverse of that power factor 0.426. So we are getting the angle as 64.78 degrees. So that is in leading. Why it is leading? So in RC circuit, okay, so it is leading. So the different the phase angle between the voltage of the resistance and voltage of the capacitance, it is always leading, no? So leading is, so phi is we are getting as 64.78 degrees. Now what is asked in the problem? Next, power consumed by the circuit. So power consumed by the circuit is nothing but I squared R or otherwise VA cos phi. Either two formulas you can use, you'll get the same answer. You can also try. So power consumed is I squared R. So I squared R is nothing but, so current already we calculated as 9.80 amperes. So and the resistance also we know 10 ohms. So it's substituting here. So we are getting the answers 960.4 watts. Now what is asked in the problem? We need to draw the impedance triangle and as well as the power triangle. So how to draw the impedance triangle? So impedance, say for example, we are taking the this voltage in the resistance in this axis VR. So VC is exactly 90 degree. Okay, so because by inserting a capacitance in the circuit, so it is exactly 90 degree. So 90 degree the phase shift between this voltage across the resistance and as well as voltage across the capacitance. So in the right angle triangle, so this VC is we can draw it over here, no? This part is nothing but this part, no? The same DC we can draw it over here. So what we are doing is we are drawing over here, this point. Okay, so resultant is what? V. Okay, this is VR. So this is VC. So between this VR and VC, what is the angle is 90 degree apart. Okay, voltage across the resistant as well as the voltage across the capacitance is 90 degree apart. So in right angle triangle, this part is equal to this part. So this line we are drawing over here. This VC we are drawing over here. So VC is what? So this is the voltage across the capacitor. So VR is what? Voltage across the resistance. So V is equal to I into R. So voltage across the resistance is I into R. So voltage across the capacitance is I into XC. So resultant is what? V, capital V. Okay. So V is nothing but I into Z. So why it is Z here? So Z is nothing but impedance. So impedance is combination of resistance and as well as the your capacitive reactance. Okay, so that is what we have seen here. Z is equal to root of R square, or otherwise Z square is equal to R square plus XE square. So in right angle triangle, so this hypotenuse side. Okay, so hypotenuse is Z square is equal to R square plus XE square. Like that also you can use. So resultant is nothing but B is equal to I into Z. So this is how you need to draw the impedance triangle. So what is the phase angle here? So phase angle, certain phase angle will be there between this voltage across the resistance as well as the resultant voltage. Okay, but these two are is in the 90 degree. Okay, 90 degree apart. That is voltage across the resistance and as well as voltage across capacitance is 90 degree apart. So what is the phase angle phi? That whatever we calculated, that is the phase angle phi. Okay. So what is resistance over here? Resistance is nothing but R is nothing but is what? R is 10 ohms given in the problem, 10 ohms. What is XC? XC is already we calculated 21.23 ohms. So that is only comes over here XC. Z is what? Z is what already we calculated. What is Z? 23.46 ohms. So that we need to write it over here. Impedance triangle. So what is phi? So phi is nothing but 64.78 leading. Okay, 64.78 leading. So why it is leading means, so in the capacitance, the capacitance current will be always leading the voltage by an angle of phi. Okay, with respect to the voltage. So that's why this phase angle also leading. Okay, leading and impedance is Z. So here from this triangle, so I and I, so all I we are cancelling out. So here also I, here also I, here also I, we are cancelled. So with this easily you can take R here. So if you cancel I here, R. If you cancel I here, it is XC. If you cancel I over here, it is Z. So this resultant is Z. So Z is equal to root of R squared plus XC squared, or otherwise Z squared is equal to R squared plus XC squared. Hypotenuse side. Okay, this is opposite side, adjacent side. Okay, so like that. So impedance triangle is what? Impedance triangle is nothing but a right angle triangle that which visually represents the relationship between the resistance, reactance, that is here it is capacitive reactance, and the impedance in an AC circuit. That is all about the impedance triangle. Now we need to draw the power triangle. So power triangle already we have seen the previous problem also. Power triangle is the representation of the right angle triangle showing the relationship between the active power, reactive power, and as well as the apparent power. In the same triangle, this triangle again we are drawing over here. Okay, same triangle again I am drawing over here. Now what I am doing is I am multiplying the current. So previously it is VR is equal to IR, VC is equal to I into XC, V is equal to I into Z. So now what I am doing is I am multiplying current on all the sides, all the three sides. So okay, I'm multiplying the current on all the three sides. So here also I'm multiplying, here also I'm multiplying. So if you multiply the current here, so we can write R in the terms of Z cos phi, because cos phi is equal to R by Z. Okay, so R is nothing but Z into cos phi. So I am replacing R with the Z into cos phi, and I am replacing with respect to V by Z. So V is equal to I into Z. So I is equal to V by Z. So I am replacing I with respect to V by Z. So Z and Z get cancelled. So it is I cos phi into V. That is nothing but VA cos phi. Okay. So that is nothing but um, uh, VR into I. So not VR. So VR into I. So VR into I is nothing but P. Okay. So here I have written wrongly. So VR into I is nothing but P. That is called real power. So here you see here, this is VC. Okay, VC is nothing but I into XC. So we are multiplying with I again. So I again. So we are rewriting XC in terms of Z into sine phi. How? So we already know sine theta. Okay, by using sine theta, we can easily rewrite XC in terms of Z into sine phi. So I am rewriting I in terms of V by Z. So I am substituting over here. So Z and Z get cancelled. So here I am getting as I into sin phi into V. That is nothing but VA sin phi. So here also VC into I. So VC into I is nothing but Q, reactive power Q. So Q is equal to VA sin phi. So here this is how we need to derive the reactive power. Next, what is the resultant? V is equal to I into Z into again I. So here also into I. So V into I. Okay. So here what I am doing is I am rewriting I in terms of V by Z. So I is nothing but V by Z. No. So this I am substituting over here. So Z into I. So Z and Z get cancelled. It is nothing but V into I. It is nothing but S. S is what? Apparent power. Okay. So S is what? Apparent power. So this is what? This is real power. VA cos phi is real power. VC is what? So VC into I is nothing but Q. Q is nothing but VA sin phi. So this is called power triangle. So power triangle, this part is what? Real power. Okay, that means VA cos phi. The unit of real power is what? Reactive power is nothing but Q. Q is nothing but VA sin phi. Okay, so here we derive now VA sin phi. Unit of reactive power is voltage, ampere, and react. Okay, next is apparent power. Apparent power is what? V into I. So representation is S. S is equal to V into I. So unit of apparent power is voltage, ampere. Okay, so similarly, so the whatever we calculated that we are writing over here. So we need to calculate VA cos phi. VA cos phi is what? 230 into V is 230. So I is 9.8. Cos phi is what? Already we found out. Already we found out cos phi is equal to 0.426. And I also we found it as 9.8. And V also already given in the problem as 230 volts. Okay. So this answer, power consumed and real power will be same. Okay, so power consumed and real power will be same. So real power is what? So VA cos phi. So here it is 960.20 watts. Okay, so here also power consumed also I squared R also we got the same answer 960.4 watts. Okay, here next we are calculating reactive power Q is equal to VA sin phi. So 230 into 9.8 into sin phi. Sin into phi is what? 64.78. Okay, so phi is what? 64.78. Already we found out what is angle phi. 64.78 leading. No, so that angle we are taking over here. Okay, and calculating Q. So the reactive power. So it comes like to 2039.14 VAR. Okay, voltage ampere react. Okay, next active power. Active power S is equal to V into I. So 230 into 9.8. So if you calculate, you get 2254 voltage ampere. So this is the apparent power. So not active power. This is apparent power. So apparent power. Here I have written wrongly. So apparent power, active power, real power. Okay. So apparent power is what? 2254 V into E. So now we are redrawing this power triangle. Redrawing the power triangle with the real values. So P we calculated no 960.2 watts. Yes, we calculated no. Yes, apparent power. Apparent power we calculated no 2254 V into E. Q we calculated, no? Q is VA sin phi. That is 2039.14 VAR. So this is how we need to draw the power triangle. So this is the explanation for the power triangle. So impedance, from the impedance triangle only we are deriving the power triangle. So just multiplying I over here, and we are calculating this real power, reactive power, and apparent power. This is how you need to solve this problem. Very simple problem, just explained in detailed manner, but easily you can solve and get the marks.